Okay, Aubrey and Aiden. This is 2-1. We're starting chapter 2 in college algebra. We got to get to rockin' and rollin'. Chapter 2 is going to be, like, hopefully a quicker chapter. But in section 2-1, they're just talking, this is an easy section. Rectangular coordinates, which just are, like, ordered pairs, regular ordered pairs, and then graphing linear functions, that type of thing, okay? So, they're talking about two variables that you're relating to each other, like a numerical score in mathematics is paired with a corresponding letter grade, like an X and a Y. Number of gallons in gas pumped into a tank paired with the amount of money needed to purchase it, that's an X and a Y. Expense categories are paired with dollars spent by the average American household in 2017. Expense categories, that would be like utilities and internet and I don't know, groceries, right? And then paired with the dollars spent, so this is an X and a Y, whatever, okay? In this case, the X's would be categorical instead of quantitative, whatever. Okay, here is that exact example. Food, housing, transportation, healthcare, apparel and services, and entertainment. That is all of the amount of money spent. And that's over the course of, what, a year probably? Right. I'm going to say that I spend way less on housing because my house is paid for. But, like, my grocery bill is probably, like, way more than that. For a year. Whatever. Entertainment. I don't know that my entertainment bill is that much. I don't know. Whatever. Okay. Use the table to write ordered pairs to express a relationship between each category and the amount spent. Okay, so housing. If I write this as an ordered pair, it would be housing, comma, I crossed it out, 19,884. And that's just the ordered pair. There you go. B would be entertainment, comma, 3,203. That's the ordered pair. Now, again, your X coordinates in that case are categories and not numbers, but that's totally legit. We can have that.
Do you really
Writing ordered pairs.
Spend that much on entertainment?
Maybe I do.
How many subscriptions do you have?
Oh, that's true. I didn't add in all my Netflix and everything.
Netflix, Hulu,
but I really don't have that many. I have Netflix, Disney Plus,
well,
YouTube TV that I only spend $20 a month on because we share it.
Your phone plan.
True. Is that entertainment?
Anything you ever go do with
not according to my taxes. According to my taxes, my phone bill, or half of my phone bill, is used for my husband's business expense. Yeah.
Yeah.
Anywho, all right, whatever. Distance formula. Do we know what distance formula is? Yeah. If we're given two coordinate points, just to show you here, like two dots, right? And I want to find the distance between them. I can make this into a right triangle, right? Like count the number of x's right here, count the number of y's, and then a squared, b squared, c squared, right? Okay? So we know that a squared plus b squared equals c squared. Now, if I'm trying to solve for c, I take the square root of that, right? Okay? And that's what the distance formula is, okay? We do the square root of this guy squared plus this guy squared. A squared plus b squared equals c squared, okay? Then I just have to decide how big is a. So I look at the x coordinates. I say how far apart is -8 and 3? 11. Right? How far apart is 4 and -2? 6. 11 squared is 121. 6 squared is 36. If I add those together, that's the square root of 157. And whatever that is.
I can do that.
It's going to be like 12 point something.
12.5299640.
We'll go 12.53. Okay, approximately. I should do approximately instead of equals, right? Whatever. Okay, that is distance. All right, now we have these three vertices going on. They want to know if this thing is a right triangle or not, right? So, like, if I have these three dots, like, does that make a right triangle? I don't know for sure, right? So what are we going to do? Okay, but, so we can do a squared plus b squared equals c squared, but I don't know how long a is the problem. And I don't know how long b is. And I don't know how long c is. No. But we can find the distances between each one, right? Find the distance from here to here, find the distance from here to here, find the distance from here to here. And then which one will be c?
The biggest
The biggest one, right? Okay, so let's find our distances. We've got to do 3 of them. MN is one of them. We'll do NQ is another, and we'll do MQ is another. Okay, we're going to have to do 3 distances, but these don't take terribly long. And we're not going to find the, find it in decimal form. We're just going to leave it, all right? If we're doing MN, negative 2 to 12
14.
is 14 squared plus
2.
5 to 3 is 2 squared. 14 squared is 196. 2 squared is 4. That is the square root of 200, right? And we're just going to leave it as the square root of 200 and not solve it, because we're going to end up squaring it when we do our other stuff. Okay? NQ is 12 to 10, which is 2, plus 3 to negative 11 is 14.
They're the same.
So that's the square root of 200 again. This is weird. We know it's at least isosceles, so I'm guessing that if this ends up being a right triangle, this will be the square root of 200, and this will be the square root of 200. And then our hypotenuse will probably be maybe different, right? So, maybe. All right, MQ. So, for the first one to the last one, negative 2 to 10 is 12. Squared plus from 5 to negative 11 is 16. So, this is 144, and this is 256. And if I add those together,
400.
is it 400?
Yeah.
Hey, perfect. Okay, so which side is side C then?
The last one.
The last one. This is C. We don't care what A and B are, so we'll just call it A and B. If I take A squared plus B squared equals C squared, if I get the square root of 200 squared plus the square root of 200 squared, is that equal to the square root of 400 squared? Right? The squares and the square root of 200 equals 400.
So what is it looking for?
It says determine whether the points are vertices of a right triangle.
Yes.
Yes, this is a right triangle. We have a right triangle. Boom. Okay, so that was a lot of like Pythagorean theorem. You had to do like the Pythagorean theorem basically when you do the distance formula. Then you have to do it again when you're checking the 3 sides. Does that make sense? Okay. And you might not know what side C is until you do your distances, right? Okay. C won't always be the last one. Got it? Okay, now, here's another weird one. Determine whether these points are collinear. Like, that means they live on a same line. Okay, so let's just hypothetically speaking, let's say they live on a same line. And I'm going to purposely put one not in the middle, right? So you don't think that they're equal distance, right? Okay. Now, if these are on the same line as opposed to, like, this thing happening, right? Right?
It's not the same.
Then the distance from here to here plus the distance from here to here has to be equal to the distance from here to here. True?
True.
That is not true if it makes a triangle thing, right? The distance from here to here plus the distance from here to here will not be the same as the distance from here to here, right? That shorter side will be shorter.
Do you have
I don't know. They might be gone. They might be gone. You can run grab some if you want to. April. Okay, does that make sense? So if they make a straight line, the 2 smaller distances added together will make the third distance. Got it? If they make a triangle, it won't add up to be the same. All right, so we got to do our 3 distances again. Let's do PQ, QR, and PR. And yeah. And I don't necessarily know which route they go. Like, I don't necessarily know that P and R go here, right? But the longest distance, right, has to be the 2 endpoints. Got it? Okay. So PQ, square root.
3. And
Negative 1 to 2 is 3. Plus 5 to negative 4 is 7. Okay, 3 squared is 9. 7 squared is 49. 9 and 49 is 58. The square root of 58.
5 to negative 4 is not 7.
9.
9.
9, which is 81, which is the square root of 90. We're just seeing if you're paying attention over there, Connor. You know, it's fine. Whatever. 90, the square root of 90. All right. QR, 2 to 4 is 2. Negative 4 to negative 10 is 6. 2 squared is 4. 6 squared is 36, which is the square root of 40.
So that one has to be a shorter side.
Yep, for sure. Yep. And are
3.
is negative 1 to 4 is 5. 5 to negative 10 is 15. That's going to be our longest one. 25 to 225, which is 250.
That doesn't.
Okay,
Yep.
now,
No, that doesn't. It's 230, right?
is it 230?
No, it's
No,
not.
it's
No,
250.
when you add up, it's 230. 90 and 40.
That's 130. But these are square roots, though. You don't add the stuff inside the square roots.
Oh, crap.
So let's actually figure out what these are as decimals and see if it works out. The square root of 90 is 9.49. We'll say the square root of 40 is 6.32, and if I add those together, is 15.72, and the square root of 250,
It's 15.81.
oh gosh, the square root of 250
Pretty
is
close.
15.8. So are they the same?
I don't know. Pretty close.
I'm gonna guess that our rounding errors like made it
Yeah,
so that they're
if
not the
you
same.
use the whole number,
If you use the whole numbers, it ends up being 15.8 exactly. Okay, so yeah, these two pieces do in fact make up the big piece, which means they have to be in a straight line, right? If the smaller two pieces don't add up to be the same, exactly the same as the bigger piece, then they would be in like a triangle form, right? Like they would look like this instead. Okay, does that make sense? Okay, okay, midpoint. Finding the midpoint is like finding the
Average.
average, okay? How do you average things?
Are you recording?
Yes, I am.
Okay.
Add
Yeah.
and divide by 2.
Add and divide by 2, okay? So, if I'm trying to find the midpoint between these 2 points, the x's, I'm going to add the x's together. Okay, now, here's the tricky part. Are you listening? Ready? When we did the distance formula, we would say, how far apart are 8 and negative 6, which is 14, right? That's not what you're doing for midpoint. Midpoint, you're adding them together. So what is 8 plus a negative 6, or 8 minus 6? 2, right? And then I take 2 divided by 2, which is 1. Do you see the difference? When you're doing the distance formula, you're finding the distance. When you're averaging, you're adding, right? Okay, so one of them you're subtracting, and that's 14. The other one you're adding, and that's 2. Okay, now if I do negative 4 and 1, and I add those together, that's negative 3 divided by 2, which is negative 1.5. This is going to be my midpoint. Okay, if this were a test, I would maybe like plot them to see if it looks like it's maybe in the middle, right? Just to see if I did it right. Okay. Find the coordinates of, here we go. Find the coordinates of the other endpoint Q of a line segment with one endpoint is P, and P is at negative 6, 12. All right? That's where P lives. The midpoint right here is at 8, negative 2, and this is not drawn to scale. I have no idea where these points live. Actually, 8, negative 2 should be lower, but whatever, it's fine. They want to know where this point is located, if M is the middle. Like, how do I find these coordinates over here?
Oh, yeah. If it's much.
Mhm,
This is what
mhm,
I was doing.
How far is negative 6 from 8?
The distance.
The distance, yep,
14.
14. Okay, so this should then be 14 units that direction. So he is now at
I don't know. 24.
22.
2.
Does that make sense? Okay, how far apart is 12 and negative 2? 14. So I got to go negative 2, or negative 14 more that way.
16.
Negative 16. Do you see how that works?
Yeah, your way is way easier than mine.
Yeah. You could do the formula, right?
I was reversing the.
You were reversing the formula, like plugging into the formula, like doing like whatever, negative 6 plus x over 2 equals 8, right? Whatever. Does that make sense? Because this is the midpoint. If you add them together and divide by 2, that's 8.
Times 2
And then you could
is
do
16.
12 plus x over 2 equals negative 2, right?
Times 8 is 6.
This would be 16, and then you add the
Plus
6 over,
6.
22,
Yeah, I was doing it
right?
a weird way. Yeah.
Multiply by 2, that's negative 4. If you subtract 12 from negative 4, that's negative 16. So you could do the formula backwards, or I'm just going to count. How far apart is these? Add it one more time. How far apart is these? Add it one more time. Make sense? Not too bad. Okay? All right, are we about?
should probably
We'll do this last one because this is midpoint, and then we'll save the rest for tomorrow. Okay. All right. Applying the midpoint formula, depict how the graph might indicate the increase in sales generated by fast food restaurants in the United States from this many billion to this many billion from 2011 to 2017. Use the midpoint formula and the two given points to estimate the sales in 2014. 2014 is exactly in between 2011 and 2017, right? So we just have to do the midpoint or just find the difference like between those, right? Find the average. We're averaging those together to find the middle.
So 230,
So I add those two together, whatever that is.
167.
167.7
Plus 233.
plus 233.7. And I get 401.4, but then I divide by 2. And you get 200.7, right? If I just find the middle. 200.7 is what he is exactly in the middle. Okay, not too bad,
Dollars?
right?
Yes, dollars.
Right. Now they might, yeah, dollars, billion dollars actually. Now that might not be exactly the right point, but we're assuming that it increases linearly from 2011 to 2017. It may not. It might do more of one of these, right?
Yeah, it's more than the average.
Right. So, it's what?
They give you the actual.
Oh, they do give you the actual. What is the actual? Oh, yeah. The actual is 194 or 185.4. Compare it. They're pretty close, though.
Yeah. But in
Pretty
billion-
close.
When you think about it,
Right. In billions.
that's 5
That's 5 billion. 5 billion off. Whatever.
more dollars.
5.3 billion off. Anyway, whatever.
You ever
Pretty close. Yeah, I'll go print it real quick. Okay. All right. Goodbye.